There we go. Try that again. Okay. 7.3. We don't know the population standard deviation. So we will be hypothesis testing again with rejection regions. Rejection regions are what we talked about yesterday with our standard normal table. So a lot of this is going to look similar. We're going to need to find critical values, but this time it's just going to be on a different chart. So the first thing we're going to do is just practice finding those critical values. We're going to find the level of significance first. We're going to name that ourselves, or we're going to be given that. Then we're going to find degrees of freedom. So remember from the last chapter, degrees of freedom is your sample size minus 1. And then we're going to put those two pieces of information together on your chart. So if you guys can find your T distribution, bless you. T distribution, you can see degrees of freedom is down the side. And then at the top, you have your level of confidence, which is your C, or you can choose below that. That's what we used before, by the way, when we did our confidence intervals. You can see the alphas are listed below that we need for a one-tail and a two-tail test. If it's a one-tail test, you use the row that says one-tail, and then you select that appropriate column for whatever your level of significance is. If it's a left tail test, we're going to use a negative value. And if it's a right tail test, we're going to use a positive value. And then there's also an option for a two tail test where pretty much they just take that level of significance and divide it by 2. And then if you have that, you're going to have two critical values. You're going to use the positive and the negative off of here. So we're going to practice doing this first, just finding the values in the table based on the type of testing that you're doing. So we'll try these ones together. So we're going to find the critical value. Remember in our standard normal table, they use a Z sub 0 or a Z null. Now we're going to use a T sub 0 or a T null for these. So what you want to know is if it's a left, right, or two-tail test, in this case it's a left tail test, our level of significance is 0.05 and our N is 21. So before you can do anything on the table, you're going to take that N and change it into degrees of freedom. So remember, degrees of freedom is your N minus 1, 21 minus 1 in this case, and that is 20. Okay, so now finding this on your chart. It is a one-tailed test, so you're going to look across the top where it says one tail, and you're going to find the appropriate level of significance, 0.05, so that's going to be the second column, and then you're going to go down until you find 20 degrees of freedom, and that's going to be the value that we use plus or minus. Okay, so in this one, let me see. Looks like I've got 1.725. Everybody see that all right? Now, because it is a left tail test, we're going to use the negative because remember this value that we're seeing is to the left of our mean if it's a left tail test. So negative 1.725, and that would be your critical value of T sub 0. Okay. Next one, we have a right tail test. Level of significance, 0.01. N is 17. If N is 17, what's my degrees of freedom? 16. Okay, so again, it is a one-tail test. So you're going to find one tail on the top. Go across to your level of significance, 0.01. So that's going to be the fourth column. And then you're going to go down until you find 16. And I see 2.583. Look good? Everybody see that number? Okay, great. So if it's a right tail test, we use the positive value, the one that we see. 2. What did I say it was? 583. Okay. And then finally, if you have a two-tail test, level of significance 0.1, N is 26. If N is 26, what's my degrees of freedom? 25. All right, so now across the top, you're going to look where it says two tails. Go over to alpha of 0.1, so that's going to be in your second column. And then you're going to go down to 25. And you should see 1.708. If it's a two-tail test, we're going to use both the positive and the negative. What did I say it was? I lost it already. 708? My old eyes can't find all these little numbers. Okay. Make sense? Finding those critical values? This is important because remember that's going to be where our rejection region starts or ends. So this is going to determine then when we calculate a value, a critical value based on our data, if we reject it or do not reject it, if it's greater than or less than this number. All right, you guys try these ones real quick. I'll give you a minute. Perfect. Good. Any questions? Finding critical values for our t-test, hypothesis testing. All right, you need your calculator for the next little bit here. So let me unfreeze that for you. All right, so like I said, we're going to be using rejection regions for the hypothesis testing. You can do this testing with p-values, which is what we talked about on Friday last week when we had our standard normal distribution. The problem with p-values and t-testing is it's pretty difficult to find those p-values, those areas that we need. So instead, we just use the calculator if you need to use a p-value. So if you see that pop up in MathXL or on test or anything, it would just be with the calculator only that you would be finding the p-value. And then just like our other tests, we compare the p-value to our level of significance once we find it. So we'll do that in a minute. If the p-value is less than the level of significance, that's when we reject. If the p-value was greater than the level of significance, that's when we do not reject. So for this one, it says Department of Motor Vehicle Office claims that the mean wait time is less than 14 minutes. A random sample of 10 people has a mean wait time of 13 minutes and a standard deviation of 3.5 minutes. At level of significance of 0.1, test the office's claim. Assume the population is normally distributed. So just like our other testing, we would want to kind of check a couple boxes at the beginning here. We first of all want to know, do we know the population standard deviation here? And the answer is no. All we know is a sample standard deviation, which is how we know we're going to be using t-testing instead of the z-testing. You also want to make sure that the sample size is either bigger than 30 or normally distributed, and they tell us that it's normally distributed here. I do think it's helpful to at least write down what your null and alternative hypothesis is and what your claim is. The claim here is that the mean wait time, so my mu, is less than 14 minutes. Is that an alternative or a null hypothesis? That is an alternative hypothesis. So my null hypothesis is the mean, what's the complement of that? Greater than or equal to 14. Okay, so now looking at the data that we're going to fill in, and we'll type it in our calculator in a second. I'm just going to kind of fill in these boxes here first. So the mean null there, or the mean that's being tested here, is 14. So that's going to go in the first box. You need the mean of your sample set, which was 13, was the mean wait time of the sample. You need the sample standard deviation, which was 3.5. We need the sample size, 10. And then it's going to give you one of three options at the bottom. You're going to choose the one that goes along with your alternative hypothesis. So we're going to choose the one that is less than eventually when we get to that. All right, so in your calculator, we're going to hit stat. We're going to go over to tests, and we did this before with the z-test. Now we're going to use a t-test because we don't know that population standard deviation, so number 2. And then you have two different options here. Data is your first option. That's if you have like a list of data and you want it to calculate your mean of your data and your sample standard deviation. It would do that for you. We're going to go over to stats because we know those stats already. We're just typing that data in. So stats, and then my null that's being tested is 14. My X bar, 13. Sample standard deviation was 3.5. The sample size was 10, and then again, my alternative hypothesis was less than that we were testing there. Okay, and then hit calculate. And what we're looking for is that p-value. And we're comparing the p-value to our level of significance every time. Did everybody get that okay? I got 0.194. Is my p. Okay, so now we compare p to alpha. P is 0.194, alpha is 0.10, greater than or less than. In this case, it's greater than, so what does that mean? Do we reject or not reject if it's greater than? Do you remember? Get a 50-50 shot. Reject or not reject? Do not reject. Good try, though. We do not reject. So you would say there is not enough evidence to support the claim that the mean wait time is less than 14 minutes, if you had to summarize that. Okay? This is the only way we will do P's is with the calculator if you've got a t-test. Questions on that? Okay, so the next set of questions then, I want you guys to try these with the calculator then. So they're giving you a claim, level of significance, they're giving you the sample statistics. So find that p-value for each of those and then decide if you're going to reject or do not reject. If it's less than, if the p is less than alpha, you are rejecting. If the p is greater than alpha, you do not reject. Okay, I'll give you a minute and I'll probably get a couple more groups to put these up on the board. All right, these look good, guys. So for the first one, P.024, that is less than my alpha, so we reject it. So if the claim is this claim an alternative or a null? Alternative. So your summary, you would say there is enough evidence to what? What word would you use? Support or reject? If the alternative is your claim, you say there is enough evidence to support. Is what we're looking for here, would be your summary of the claim. Now down here, the claim is the null, and we do not reject it because we get a value that's greater than our level of significance. So you would say there is not enough evidence to reject. Okay, so it's going to be very careful with the wording. So there either is or is not, depending on if you reject or do not reject. If your claim is the alternative, you use the word support. If your claim is the null, we're going to use the word reject. All right, so last problems we're going to do today is we're just going to do a little practice with rejection regions, and that's what we're going to do tomorrow. We're going to do the full-blown hypothesis testing with our T's, putting this all together. So let's say you're not using a p-value, you're going to use the critical values. We already practiced finding those critical values, and you can see them listed on these little normal curves at the bottom here. So now we're going to look at, based on a T that we calculate from our data, if we get these, would we reject it or not reject it? And remember, if it's in the rejection region, you reject it. If it's not in the rejection region, you do not reject it. So for the one on the left, if my T is 1.4, and I look at that curve on the bottom there, is 1.4 in the rejection region? It is not. So we do not reject. I'll just put the word not there. Okay, what about 1.42? Is that in the rejection region? Yes, so we would reject it. What about negative 1.402? We do not reject, not in the rejection region. Okay, the one on the right is a two-tailed test. Negative 1.755, is that in either rejection region, in either tail? It's going to be in the left tail. It is less than that critical value on the left, so we reject it. Negative 1.585. Do not reject. Good. It's going to be in the middle. And then 1.745. Reject. And we'll stop there for today. Okay. Tomorrow we'll put this together. We'll do some hypothesis testing. You guys can get started on the 7-3 homework. If you want to, you can do a lot of this little stuff at the beginning. So reminders about deadlines, 7-2, all of that is due on Wednesday, tomorrow night. 7-3 is due on Friday night. So you've got one assignment due Wednesday, one assignment due Friday. All right, you guys have 25 minutes now to work. Use it wisely. Yes, ma'am.